So we're going to be talking about trying to establish some sort of reasonable, defensible framework for brainwave, ethical framework for brainwave technology. And the whole reason that I'm doing this and Ari's doing this is that about a year and a half ago, I guess, the Interaxon, which is a company that does thought-controlled computing, basically EEG interfaces to computing devices, came to Matt Semaphore and asked if they knew someone that could help them sort of establish a position around the ethics of brainwave technology. I'd done a lot of kind of white papers and position papers in the past, so Adam had raised it, and I thought, well, okay, I'd like to do that. That'd be kind of fun. So started the position paper. The whole idea behind Interaxon doing this was to eventually establish an arm's length body that was that would be responsible for facilitating dialogue around brainwave technology and the ethics associated with it. So what I'm going to do is kind of lead you through my own, I don't know, journey of discovery, if you will. Kind of try and position the technology. Oops. Try and sort of understand, position the ethics around that, sort of arise out of the affordance of the technology. Propose some principles and guidelines for its ongoing development, but these are proposals only. They are certainly not a de facto standard. They start with the imagination. And I'm expecting some pushback, or I would think I'd get some pushback from any technology libertarians out there that want to make sure that the technology is not hampered by stupid considerations that don't bear any relation to reality. But I hope that the principles, at least, are reasonably defensible. And then finally, Ari's going to introduce the Center for Brainwave Ethics. So Ari is actually the executive director for the center that is in its very nascent form still, but is essentially in the process of being established. All right, so if we talk about the technology itself, so the evolution of human-computer interaction, really almost every form of interaction we have with a machine is physically mediated. Whether it's through voice, whether it's through a keyboard, a mouse, whether it's a tablet with a stylus, whatever. Even if you go through sort of, well, we'll get to that in a sec. So, but it's evolving to move from sort of an imposed framework to a more naturalistic framework. So rather than I am going to force you to hit a particular menu item with a stylus, I'm going to allow you to gesture. I'm going to allow you to do something in a more natural way to indicate a preference. It's also moving from explicit to implicit. So there is contextual bound factors that, for example, if a gesture in one context may have one meaning, a gesture in another context may have another meaning. A voice command in one context may have a meaning, a voice command in another context. So, and it's moving now from body-mediated solely through physical action to more mind-mediated. So direct interactions between sort of your own, the intimacy, I guess, and ephemeral nature of your own mental processes as input to the device. And if you sort of look at kind of the systems and gadgets that are moving in that more naturalistic, they still look clumsy, right? I mean, they still look kind of absurd. So most physical interfaces tend to be, I think, clumsy, distracting, and they demand a physical capability. They demand a physical affordance of some sort. So what if we could kill it? What if we could kill the device, disintermediate, and go straight from the brain to the device? That would be kind of a good thing to do if we are talking about naturalizing human-computer interaction. So on the one side, we've got the scary stuff over here, which is the direct neural implant, as one method for extracting information from the brain and channeling it directly to a device. On the other side, we have a less invasive method, which is really what we're going to be talking about today, which is brainwave technology. And I thought this was a nice representation of the cyborgian angst we all feel about this. But, so, mind, machine, and why is that thing up there? Go away.
Hit allow, click allow. And then that'll go away eventually.
Good. So I guess one of the questions that arises from this is as we move from a body-mediated to a more mind-mediated form of interface, does that represent a paradigmatic shift in a Kuhnian sense, or is it purely an evolution, a natural evolution of the technology? Ari hates the word paradigm shift, and I can't blame everybody else, I'm sure, does too. But it is worth questioning about. I mean, are the affordances that come along with a mind-mediated computer interface really on a different scale, or are they an extension or on a completely different scale? And I think that question is worth asking philosophically. So, in brain-machine computer interfaces, here are some of the, it's a very, very active area of research. It's a very, very active area of commercial application. And what I want to say is what I'm going to be talking about in terms of the ethics today really relate to consumer-oriented, consumer-level devices. We're not talking about medical research. We're not talking about the application of research within a bona fide research context, because they have very serious ethical frameworks already established for allowing or disallowing certain forms of research to go on about the concern over human participants, et cetera. But within the kind of wild west of consumer-oriented devices, you've got an entirely different world. And it's really looking at how the consumer-oriented device plays or doesn't play with a particular set of ethical standards that we're concerned with today. So, what are the consequences of moving to a more mind-mediated world? Well, you get liberation from the imposition of body mediation. So for some people, that's critical. If you have people who are incapable of acting physically, that's an enormously liberating thing. You have, perhaps, the resulting increase of agency and autonomy. If I can control a prosthetic arm, or I can control even, let's say, an entire robotic exoskeleton, or if I can turn on or off a device simply by thinking about it, for someone who doesn't have the kind of physical affordances that other people might have, that's going to be an enormously liberating thing. But it also redefines, perhaps, what it ultimately means, what is ultimately human possible, but also what it ultimately means, perhaps, to be human. So if we start incorporating devices into our own conceptions of our body image, of our mental image, what does that mean for us as a species? What does that mean for us in terms of our conceptions of what it means to be human? So, BCMI I'm going to call as an emergent technology. Why is that important? Because it's in the kind of realm of emergent technologies that it is a bit of a wild west. Emergent technologies, by their nature, are innovative. They're transformative, they're catalytic, they're often interdisciplinary, they're fast-moving, they are extremely creatively energetic areas of development. But as a result, they're unpredictable. They're difficult to categorize. They can challenge your existing norms. And I think, as a result of that, they do place a special responsibility on developers, even though the developers themselves are just like, let's go, go, go. The problem is that that's the attitude. And I think that's problematic. So, and I want to make clear, so we're going to be talking about brainwave technology, which is really the transformation of electroencephalogram signals into actionable computer or device inputs. I'm no expert in EEG, I'm no expert in BMCI, but, and so I just want to make that clear. So if you have technical questions about EEG, don't ask me. I'm going to talk. But I do have some sense for what because I've done the research, I have some sense for what the technologies are capable of. And I want to walk you through some of that. So what is EEG? Your brain generates electrical activity as it functions. Neurons are essentially electrical conduits. And it creates small changes in voltages. So if you have a pair of detectors on either side of your head, you can detect the voltage difference between those. And as your brain functions, those voltages change. But it also means that EEG is an aggregate technology. It does not allow you to detect the action of a single neuron, or as even regionally, it's not that precise in terms of laying out a precise map of activity. It is the result of the detection is the result of the synchronized activity of a lot of neurons. So its resolution is not huge. But it's getting better and better all the time. And I just want to leave you with that sense. If that's what I leave you with today, then I think that's really, really important, is that the resolution, both temporally and spatially, is improving all the time. So you can detect that neural activity, and you can interpret it and utilize it. So in the crudest possible drawing, which is a classic Google Docs drawing, this is kind of the system components for an EEG-based computer system. You've got basically a way of detecting the voltages, you've got it going to some sort of device that captures and stores it, you've got the possibility of communicating that to some sort of data storage and processor, you've got some sort of data interpretation algorithm or application, you've got devices that you can send the input into. So what is EEG, what do they produce? Well, they produce data. In its raw form, it looks like that. You've got a whole series of voltage changes, which actually often coalesce into types of frequency bands. So the way the EEG is classified, they oscillate at certain frequencies, and you've got delta bands, gamma bands, each of which occupies its own frequency level. So you can take that data, and these days you can take it and parse it and interpret it and provide some output. And provide it as an input once it's interpreted into specific devices. So you've got mobile apps, you've got devices that detect EEG and provide a mobile data output. You've got dashboards because there are ways to loosely couple the presence of a certain type of oscillation frequency at a certain level in combination with others to give you some sense over affect, to give you some sense over concentration, some sense for anxiety, some sense for cognitive arousal, whatever. So you can take that data and package it. So you can determine state of mental activity, concentration, arousal, mood state. You can make in a medical context, some fairly precise diagnostics around neuropathology, epilepsy, tumors, stroke, deep lesions, early stage Alzheimer's, for example. And determination of intent, action perhaps, and down the road communication. We'll talk a little bit more about that later. So you can provide insight into your own or someone else's cognitive functioning, or affective functioning, or absence of cognitive functioning, or absence of affective functioning. You can diagnose specific neuropathologies. You can drive devices, both physical and virtual, and perhaps eventually communicate, quote unquote, through something called imagined speech. And there's a lot of research actually in imagined speech right now. DARPA funded a fairly sizable effort to look at that as a possibility. But we have to sort of differentiate between the consumer level and the medical level of this. So in the context of medical use of EEG, it's very, very precise, it's highly targeted. You need a lot of specialized expertise to diagnose a particular type of epilepsy, for example, or an epicenter for a particular seizure. There are significant consequences for the person undergoing that testing in terms of the accuracy of the diagnosis. That has profound implications. Consumer level, blunter, broader. The feedback goes direct to the user. There's no interpretive layer there, except for the algorithms that have its own problematized, perhaps, either empowered or problematized affordances that go on. It's less significant in terms of, arguably, less significant in terms of its impact on the end user. So it's kind of, you can classify it as part of the quantified self movement, which is sensors for everything, basically. And I can basically parameterize and quantize virtually every aspect of my functioning. This simply extends it into the realm of the public. So let's just, I think in order to sort of understand maybe some of the ethical issues associated, I think we can walk through a variety of uses for this technology. In terms of consumer applications, gaming, obvious one. The image on the left is a beer tab that people can turn on or off using EEG. It's a nice Interaxon uses it as a sort of way to get people engaged with it. Very simple action, but still, for a lot of people, that's a very profound moment. You can use it to grossly classify mood, anxiety, stress, blah, blah, blah. So you can have your own sort of self-diagnostic window, if you will. Commercial applications, you can use it to monitor employees, state of arousal, state of fatigue while they're driving, obvious, driving heavy equipment. Are they reaching a point where their cognitive load exceeds their ability to execute the task? Are they distracted? Are they so tired they can't function anymore? Are they under the influence of benzodiazepines or other forms of drugs? You can use it to neuromarket, and not just market, neuromarket. The claims for which vastly outstrip the reality, but still, doesn't matter. It's kind of there is something there. But you can also use it more precisely these days. Research is showing that you can use it as a biometric marker, a biometric signature. So you could use it as part of a security framework. So the most common example is unlocking a vehicle, allowing someone to operate a particular type of vehicle, allowing someone to customizing a desktop workspace, virtual desktop workspace based on the recognition of user information. So that's encroaching on something other than a very loose interpretation of the data. Consumer medical applications, self-diagnosing sleep problems would be a good example. Do I have sleep apnea? How much REM sleep am I getting? How much movement do I get at night? How much disturbed sleep? How much whatever? How oxygenated? It's because you can find oxygen sensors, incorporate all sorts of things. But really profoundly concerned with, because there are markers for different stages of sleep through EEG. So as a consumer device, I would be interested in knowing what my sleep pattern is like. Biomedical applications, well, you can see from the esoteric, sort of control of prosthetic limbs, less esoteric perhaps, but perhaps as profoundly impactful is understanding the difference or understanding the role of my EEG in, for example, on diagnosing an ADHD person. Can I use it as a way of improving my concentration, my child's concentration? Can I use it as a diagnostic, sort of pseudo-diagnostic instrument? Collaborative applications, imagine speech. There's, like I said, there's certainly a lot of work being done on that. And you could imagine sort of crude forms of encoding and decoding certain forms of speech. But you could also use it as perhaps as a way to elucidate the emotional state or affective state of the person sending the message. So along with the message, you get a mood state. Along with the message, you get a profile of the person's arousal state. You get a profile of whatever. So there is ancillary data that can go along with the message to provide context and to provide, so you could, the determination of whether someone's being ironic would be a release. So, but we can try and separate the reality and the real and the hypothetical. So here and now, and then somewhere in some time, if you follow that trajectory, maybe this is kind of the path, I don't know. Sort of cognitive affective feedback is kind of a crude use in terms of consumer to device level control, to biometrics, to more refined prosthetic control, for example, device control, more refined diagnostics, and then maybe ultimately collaboration, imagine speech, incorporation of a much larger virtual world into my brain space. But let's take a look at some of the scenarios that emerge from the possibilities of this technology. What if you could use consumer EEG data to detect early stage dementia? Something encoded into the data, even though I can't do that now, and even though the algos that are available for a consumer can't do that now. What if we could? What if someone wrote something to scrape that? Because a lot of motivation for people when they're using this kind of technology, quantified self-movement, is to share it widely. But if that data has embedded within it other revealing things that I may be unintentionally disclosing, not necessarily a good thing. What if these were adopted by commercial government to further some sort of actuarial analysis, or to determine who's at risk for whatever it happens to be? There's a whole new level of surveillance that's going to be done. What if you could infer identity downstream? Oh, I know that's Joe, or I know that's, or whatever, right? That's embedded within the data, even though it's not by that kind of biometric signature isn't available yet. It's certainly possible. What if I could co-opt an identity by co-opting someone's biometric profile? What if I could use that as a way to support fraudulent transactions? What if I could hack an EEG application to undermine or transform feedback to that user, to screw them up, basically? And there is a paper written specifically about these kind of digital attacks. What if I use it to incorrectly self-diagnose cognitive affective problems? I run panic to my doctor because I believe I have at risk for early stage Alzheimer's, when it's really the accuracy of the algorithm that's problematic. What if I could self-stimulate? And there are applications already that sort of try and do this. Allow a gamer to keep functioning, or keep their arousal state, or allow a driver to maintain cognitive arousal, my state of cognitive arousal. What if I just have no idea who I was exposing potentially? So if we come back to consumer applications, and we look at, okay, so here are some of the kinds of applications. Well, what are the ethical considerations that go along with Well, privacy, confidentiality is immediate. What's the nature of the data? What's hidden in it? What's the possibility for cross-correlating that data with other data sets that I may be sharing anyway? What's the ability to actually provide informed consent or not? Often sharing sites like Strava or other forms, their underlying business model is not really about sharing data. It's about other things. And those other things, what about making use of shared data for, as employers did, looking at people's Facebook profiles as a way to pre-screen? Now, I mean, that's an obvious thing now, but I don't think when people were sharing images of themselves puking over a railing, they really understood that that was what it was going to be used for, simply the intent to share. So, what's the responsibility of commerce proposed? So, maybe it's important to educate users and the general public on brainwave technology and such. The type of data that's being generated, the mechanisms that are used to interpret it, and the potential consequences for its responses. So that everybody has a bit of a better understanding of what they're sharing, when they're sharing. In commercial applications, employee monitoring, productivity enhancement, quote unquote, biometric signatures for security, hiring, promotion, firing others. Again, confidentiality, the ethical issues are confidentiality, privacy, agency autonomy, consent, what's the nature of the data, and then who, and this is often really problematic in an employee sense, who has control of that data downstream, right? Who owns the data? Do I have any rights to that data at all? Or does that become part of my employee profile and I never have control over it? So, resulting responsibility is to clearly and transparently identify the use of the technology and the resulting data on the part of the corporation. Ensure that consent and opt-out provisions are clearly identified and supporting and protect the data at a level that is commensurate with highly sensitive personal information. That's a proposed responsibility. Consumer medical, now you're starting to sort of get into pseudo-diagnostic areas. What's my cognitive affective state? What's the level of my concentration? Do I have a specific disorder like sleep apnea? Do I have a problem with early stage neuropathology? Again, confidentiality, privacy, agency autonomy. The accuracy of the interpretations, super critical. And we'll talk about that in a second. Post-diagnostic follow-up. So what do you have to do? If you make a claim about a person's functioning, what do you have to do? Does that end? Does your responsibility end there? Or your sort of engagement end there? Or do you have a responsibility to follow that person? So we believe that you have to have there's an ethical responsibility to ensure that the claims are not spurious, misleading, and that the methods used to support those claims are developed in accordance with acceptable standards for safety, agency, and privacy. Biomedical applications. This is kind of a more philosophically interesting one because it does perhaps extend the sort of notion of the body image to any connected physical or virtual device. But the ethical considerations that go along with that are who has the rights to that technology or not? Is there a digital divide? Do we have a responsibility to allow everybody to get those affordances? What does that mean for conceptions of enablement, disablement, augmentation? Is there any kind of an issue around that? So changing conceptions of humans. And what are the possibilities that in the general public arise out of that? Possibility of apprehension, fear, misunderstanding. So we think the brainwave development community should be actively engaged in dialogues that address questions of enablement and augmentation. And then collaborative applications. So mind read, silent communication, even if it's context only, even if you're only sort of feeding people context around the message that being sent. Now, there was anybody read the University of Washington study where they had one guy with an EEG headset, one guy with an EEG headset, but also transcranial stimulator. The guy at the one end, on the other side of campus, the guy on the one end is deliberately imagining he's playing a video game, hits the space bar to shoot an alien with his right index finger, and prompts movement of the right finger of the person that's on the other side of the campus. Through, which is really data encoding, data decoding stimulus, right? I mean, that's really simple, but it's still profoundly does profoundly change, I think, our conceptions of what is possible. So, there needs to be an active, informed, and ongoing dialogue between developers, research, academic, and user. So, and then, finally, what are the ethical issues associated with the nature of EEG data, Brainwave data? Well, possibility for an electronic or biometric signature, voluntary disclosure of information, because we simply don't know what's embedded in that data yet. Obviously, there's privacy and confidentiality concerns. There may be a collapse of the distinction between intentional and non-intentional disclosure because you can't control what's being shared or being put out there. Issues of agency and autonomy. The perfect analog is DNA, right? So if I have my own DNA analyzed, there's an entirely rich data set embedded in that may disclose my propensity for particular illness, that may disclose my background, may disclose my racial profile, may disclose all sorts of data that I may or may not want to share. But just putting it out there has consequences. So we think it has to be handled in a way that reflects its current potential sensitivity. Okay, if we take it all together and sum it up, there's that list of both applications and ethical concerns. But if you distill it down, this is what you get, I think. It's the issue of the integrity of the person with respect to agency and autonomy, consent, safety, privacy, and confidentiality, and there are implications with development of brainwave technology. If we start to look for, well, what kind of principled framework might be able to help us make sense of those issues and frame those issues, there is a set of 4 principles by Beauchamp and Childers in the 80s came up with a biomedical set of principles. Autonomy, right for an individual to make their own choices, beneficence, act in the best interests of others, non-malfeasance, do no harm, and justice. It's not the only one, and there are lots of critics for Beauchamp's and Childers. Lots of people who say that, well, yeah, but they're too loose, they don't really provide enough of a framework to develop an ethical code of conduct out of it. But I think they have withstood this test of time. They're still being actively used in a broad range of contexts. Maybe it's not a bad place to start. And again, we're only starting with that one. We're not finishing that. Other relevant frameworks are privacy frameworks. For example, PIPEDA in Canada, HIPAA in the US. But they're all essentially based on, and the standards for medical information are much higher than the standards for general public identifiable information. But they're all really essentially based on the OECD, Organization for Economic Cooperation and Development, which really have 8 principles. Limit the collection of the data. Make sure that data is high quality. Make sure you tell people what the purpose of that data is. Make sure you limit your data collection to that data and that data only. Make sure that you protect it. Make sure that you can allow people to come in and look at your records to verify that it is in fact accurate. Make sure that you get the people to individually participate in that process, and make sure that people are accountable for all of those principles. Other standards, safety standards around hardware. Any electronic device does have a responsibility to adhere to specific standards around safety. So if we distill all of that, we come up with a set of principles for brainwave technology. This is our best attempt, as of now, to do that. Brainwave technology must respect the individual and his or her integrity, based on 4 pillars: agency, autonomy, privacy, and safety. So you can, perhaps we'll argue about whether agency and autonomy are distinct and separate constructs, or whether they should be conflated. Some people should say they should be conflated, other people think they should be separated. Privacy and safety. Principle 2, there's an obligation for those developing any technology to be clear and honest about what is known and not known about the technology, and to make claims that are reasonable and justifiable on the basis of existing evidence. Where a claim isn't supportable, it should be at least acknowledged. We are unclear as to whether this is appropriate. Some kind of confidence in their point. Principle 3, those developing brainwave technology have an obligation to help users understand the technology. Technologies can be extremely difficult to predict. Developers should try to be cognizant of downstream applications and implications of the technology. and try to proactively establish behavior. So that's sort of the summation of those principles: integrity of the person, agency, autonomy, privacy, safety, honesty and clarity, informed decision-making, proactively engagement, potentially. So that really brings my portion of this to an end. And out of going back to sort of the beginning again, the whole rationale for doing this was because Interaxon had a belief that it was important to start engaging with questions of ethics about the notion about brainwave technology and how it was going to be utilized. They wanted to essentially begin to build a framework for discussing these issues and to eventually develop a center for brainwave ethics. And Ari Gross is the executive director of that center, and he's going to talk about the next.
Great, thanks, Dirk. You'll have to excuse me, I came over a cold about 2 weeks ago and I've got this annoying lingering cough, so if I start coughing, it's not something I need my coffee. Yeah, you should probably learn all the all right, so I came into this project, I'd say about a month ago. I sort of was looking for interesting things to do, having recently completed my dissertation and defended, and I found that people in Toronto were starting a center for brainwave ethics, and they needed someone to help run it, to be the executive directors, do the day-to-day. And this sounded totally up my alley. I have a background in history and philosophy of science, and I'm really interested in all this kind of stuff, so I figured, why not? And that's sort of how I got involved in all this. So what is the Center for Brainwave Ethics? What this is going to be a non-partisan, not-for-profit organization devoted to ethical brainwave governance, basically. So the goals of the center is to provide ongoing ethical research and guidance into best practices in the field of consumer brainwave technology, to sort of create and facilitate these discussions about ethical use of brainwave technology, which is something that we've tried to start doing with the white paper, and to act as a bridge, I think, and this is very important, between industry, research, academia, government, and the interested public. And I really think it's important to act as this bridge, because there's a lot of different groups that are doing very different things. And I think it's absolutely critical to have some sort of center that gets people together and has them talk about it. So I was trying to think what the best way to present the center is, and I sort of came up with 4 different ways to look at the Center for Brainwave Ethics. The first is, you can see it as an open access, nonpartisan ethics think tank. So to work between all these different interested parties, government, industry, researchers, scholars, the public, and so on, to really start addressing ethical concerns and try to generate some solutions. And critically, without institutional, political, or commercial bias. Instead of having one particular institution or one particular party or one particular organization say, this is how we think things should be, this is just, we're going to lay down the law in terms of sort of ethical practices or just practices in general. It makes sense if at all possible, and I think it is possible because there's relatively few players right now. There's only a very few small amount of people who are philosophically interested in this kind of thing, or at least actively working this kind of thing. To get those people together and sit down and say, all right, well, let's talk about this and see if we can draft some sort of, get some ideas about this moving forward. I don't expect that everyone will be exactly in agreement on what the issues are and what to do, but talking about it is a great place to start. And I think that you can get something out of talking about it. It also has to be a place where people can sort of speak openly about their concerns, aspirations, and thoughts on the use of ethical brainwave technology. A place where people, everyone from the sort of absolute paranoid technophobes to the pure technological libertarians can give their input and say, this is what I think this technology should do, this is what I'm concerned about. And I think if we have a spectrum of voices, then obviously you can't appease everyone, but you certainly have to listen to everyone. Because I think that if you're going to be an organization of public trust, you really try to have to be publicly involved and solicit input from lots of different people. And I think this will probably be fairly self-selecting because it's a fairly small issue, not in terms of its consequences, but in terms of the people I think are interested in it now. And we need community input to know what matters and what to get, to know what matters and to get involved in creating solutions to potential problems that may arise. And by community input, I don't just mean men on the street, I mean community input from industry, from researchers. Because a lot of these, if you have people who are worried about mind reading, essentially, can I read your PIN number for a bank account just by putting a device in your head? And you have to then go to people in industry and say, does this work like that? And the people will probably come back and say, no, it doesn't. You can't mine your deep memories using these devices, at least not in any conceivable way, given the present state of this technology. If I showed you, 4 different numbers, PIN numbers, you might have a particular spike on some particular frequency when we showed you yours, though. So that might be something, to even know what discussions to have, you have to talk to the relevant people involved. The second way you can sort of see the Center for Brainwave Ethics is a group for generating policy for industry and research. And this is sort of regulatory policy, probably not strictly legally, defined in the same way that lawyers and doctors and sort of professional organizations self-regulate in that way. But there's a lot of professional organizations that self-regulate in informal ways that aren't granted by sort of government charters. For example, I know the Customs Broker Association, so customs brokers, people who deal with import-export and all that, they have an organization, they sit down, they regulate themselves in Canada. And so I think this is something that is very important for the Center for Brainwave Ethics if it's to have any sort of clout going forward to become, and do it at an international level. So we want to develop clear, meaningful, and achievable ethics standards for consumer-oriented brainwave technology. And I think that clear, meaningful, and achievable all have to be emphasized. You have to tell people exactly what we need to do. It has to not just be sort of a fig leaf, if you will, or some praxis, but have some consequences, and it has to be realistic. You can't tell everyone they have to have everything, all their data encoded to CIA level or whatever, encoded. You have to work with people in best practices. So this requires working with, again, companies, developers, researchers, philosophers, etc., to sort of draft, sensible and detailed policy, and work with people who sign on to this policy. And the goal is to get industry and research and so on to sign on to the policy that they, of course, are help create, bring everyone sort of under this fold, and help people to advise, help people to implement this policy through advising and just generally giving assistance. It does no good to lay out a set of rules if you can't actually help people walk them through and say, okay, here are some of these principles, here's what you can realistically do in your technology to help meet these principles, to help satisfy them. And I think that's something that you started doing with Interaxon. Once we've written the white paper, we've said, Interaxon says that's cool, how can we actually have our standards, how can we meet these standards? And that's a good question, let's work through that. I think a third way to look at it is, of course, these are not mutually exclusive. A group for educating people about brainwave ethics, doing things, like we are, sort of a relatively informal way here, talking to people about, brainwave technology, and letting people, especially the broader public, people who are going to use these things, who are going to hook EEGs up to their phones, up to their iPads, up to their computers, generate data and use it. Let them know what they're getting into when they use brainwave technology, including its potential downstream effects. Like Dirk said, it's one thing to simply have a device that records some of your data. It's another thing if that data is then passed on to a third party or taken by third-party developers, and marketers, people who may use. It could be potentially used to, as a biometric signature. We have to be pretty clear about. People have to be pretty clear about what is possible and what is legal and what is realistically achievable. What can be done with their data here. So this requires educating people about also the truth and accuracy of the claims made by companies and developers. I think that's a particularly important, at least to me, issue. People will claim crazy things about new technologies coming from a background history of science. Even if anyone knows anything about the history of medicine, the first thing that happens when anyone creates any new technology is they claim it can cure everything, absolutely everything. And brainwaves are not going to be the key to everything. These things have to be investigated, and I think we have to, hold people accountable when they make claims that are insane, and at a more moderate level, check people's claims when they make claims that are slightly, that are unqualified. So, you don't want to engage. Also, even from the industry's perspective, the industry doesn't want to be in a situation where it's like a baby Einstein situation, where this hugely, successfully marketed thing then faces a giant lawsuit because all of a sudden kids that were promised to be smarter are not smarter than their peers. So I think that's an impetus for industry getting on board. So again, this means engaging with public industry research and so on through our website, which we're going to have everything that we publish open for free, because it should be, and through social media, sort of Facebook page where people can talk and share concerns and all that, Twitter, all the usual, fancy social media stuff. You can tell I'm probably not on Twitter yet. Our website is not up yet. It's coming soon. It's in development. We have a nice layout, and the back end's mostly done. We just haven't launched the Center for Brainwave Ethics, and when we do, the website will go public. And the fourth way I think you can think of us is an advocacy group for ethical brainwave technology. Not an advocacy group, I should say, for any particular company, for any particular researchers, but in general for ethical use of this technology. So I think of this as praising the good and scolding the bad, but first trying to help the bad. You need carrots and sticks, I think, to get people to act in ways that make sense, according with standards that are generated by everyone involved. But of course, we have to do your best to go out and help people sort of get on board. So it is our responsibility to call out questionable or downright egregious practices, but I think it's as much our responsibility to defend when people do things right. And I think this is the power of this kind of organization. So this will involve raising public awareness for instances of ethical and unethical uses of brainwave technology, things we can of course talk about on our website, Facebook, and so on, and advising courts, politicians, and so on, if and when they eventually decide to deal with these issues. Because at some point down the line, someone's going to try to legislate about this. Probably not next year, probably not in the next election cycle, but sometime later, people will say, wait a second, these are things that can read our minds, and we need to think about what to do with this technology. And at this point, we can step in and say, okay, well, we have a bunch of people who are on board with some practices developed by a wide group of people and agreed to, and so perhaps you consider these. So it doesn't just be regulated by organizations that really have no idea what they're doing, which is how that unfortunately sometimes turns out. So I'm just going to leave on a simple note saying that we are starting up now. The situation for this organization is, I think we're going through a second review of our corporate governance things, our corporate bylaws. We are working on our policy. It's a not-for-profit corporation, so we're not interested in making money, but it is going to be incorporated as makes sense. And I want to say that you can be involved, even if you just want to stay in the loop. We're glad to send you emails, and if you're at all interested in getting further involved, kind of being involved in the discussions and all, please by all means. And as a bonus, we're based out of Toronto. Yay! So you don't have to walk very far to speak to any one of us who's involved. At least any one of us who's involved and don't have completely time-consuming day jobs like Ariel. So that's all I want to say for now, and I'm looking forward to any questions you might have. Thanks.